Today we will discuss about the chemistry, surface chemistry. Surface chemistry deals with the study of phenomena occurring at the surface or at the interface of two boundary separating solutions. That means this boundary between two bulk solutions. So the two bulk solutions, they may be pure compounds, solutions, or any type of combinations of solid, gas and liquid. The interface would be taken as two bulk phases. Two bulk phases means one is solid, another is solvent. So this phenomena occurring at the surface or at the interface is known as surface phenomena or surface chemistry, that deals with dissolution of solution, crystallization of solutions, corrosion and adsorption. So today we will start with adsorption. It is a surface phenomena in which any atom, ionic or molecular species is adsorbed. That means it is attracting between either of the solid, liquid or in the solution of two phases, bulk phases. So in that cases, the substance at the surface is adsorbed, is known as adsorbate, and on which the substance is adsorbed is known as adsorbent. So there are two things, adsorbate and adsorbent. The substance which is adsorbed on the surface is known as adsorbate. And the substance on which surface is adsorbed is known as adsorbent. Examples: suppose we will take the consideration of ammonia gas is adsorbed on the metal surface, whereas it is absorbed by the water. And absorbed by water, forming hydrated molecules, that is forming ammonium hydroxide. So ammonia is adsorbate and the metal on which it is adsorbed is the adsorbent. And also we will take the color of sugar. Color of sugar is adsorbed by animal charcoal, whereas it is absorbed by any fibers. So, color of sugar means that is the adsorbate and the animal charcoal is the adsorbent. So, in this way we will differentiate the two, adsorbate and adsorbent, but we have already observed that some substances, as we take the filter paper or blotting paper, whenever you will patch over ink or water, it soaks the water molecules. That means it is absorbed. Sometimes you have observed that whenever you are taking some small instruments or thermoflask, a small packet is there. That packet is known as silica gel. Why it is kept inside it? Because it absorbs the moisture at its surface. So, that is adsorption. But here in the case of the filter paper absorbs water, that is absorption. So, there is two distinct idea about the adsorption and absorption. So, in that cases, what are the difference between the adsorption and absorption? Differences between adsorption and adsorption. First we will take adsorption and absorption. As you have observed that first case, it is a surface phenomena. Surface phenomena means it occurs at surface and it is a bulk phenomena. Second part, the concentration at the surface is greater than the bulk, whereas it is uniform, concentration is uniform throughout the system. Third point, the equilibrium attains very at very short time. But here the equilibrium attains slowly. Fourth point, whatever the amount is adsorbed means considering the amount adsorbed with respect to the amount of the adsorbent used, that is the x by m. X is the amount of adsorbate, m is the amount of adsorbent versus pressure curve. Pressure plot gives curve. Pressure plot a curve, whereas this x by m versus pressure gives a straight line. Because it is uniform throughout. So, these are the points of absorption and adsorption. Also, we know there are two types of, either it is positive adsorption or negative adsorption. What is positive adsorption and negative adsorption? Whenever the concentration of the solute is more at the surface, that means whenever it is occurring at the surface, the concentration of solute particles which is attached to the adsorbent, that is more than that of the bulk. That is why it is known as positive adsorption. But sometimes the adsorbent also take out the solvent molecules, so that the concentration of solution is more than that. That is known as negative adsorption. So, as you have observed, the adsorption is a exothermic reaction or exothermic process. Why it is exothermic process? Because heat is generated during the adsorption. Because the free energy change is more negative, simultaneously the entropy of the system is also negative. Combining both, the change in free energy is more negative. That is why it gives a heat energy. So, what are the characteristics of adsorption? First point, adsorption is a spontaneous process. Adsorption is a spontaneous process. That means whenever you are taking the solution by addition of adsorbent, it immediately within known time it adsorbs. And second point, it adsorbs at all surfaces. Adsorption is taking place in all interfaces. All interfaces means either liquid or liquid gas or solid, liquid and solid gas, any combination. Third point, it is accompanied by decrease in free energy. Accompanied by decrease in free energy, that is delta G. Simultaneously, it is also accompanied by decrease in entropy. Decrease in entropy. Considering Gibbs-Helmholtz equation, delta G is equal to delta H minus T into delta S. According to Gibbs-Helmholtz equation, decrease in free energy is equal to decrease in enthalpy minus T into delta S is entropy. If we will have more delta S negative, then delta G is more negative while in the reaction. That is why energy or heat is liberated in the process. That is why it is exothermic. Therefore, the adsorption is a exothermic process. Exothermic process. So, another point is that the molecules or solute molecules, whenever it is attached to the surface of the adsorbent, what happens? Either it is attached by van der Waals weak forces or formation of any chemical equations, that is formation of a bond or breaking of a bond. In that cases, the force of attraction is weak van der Waals force. Weak van der Waals force and forming chemical bond also. So, therefore, considering this weak van der Waals force and chemical bond, the adsorption is having two types. So, types of adsorption. Types of adsorption, it is of two types. One is physical adsorption, and another is chemical adsorption or chemisorption. So, physical adsorption is due to weak van der Waals forces. Chemical adsorption is due to formation of a bond. So, there are so many differences between these two. So, the differences between the physical adsorption and chemical adsorption. In that case, we will discuss it point wise. So, in that cases, physical adsorption, it involves weak force, weak attractive force, known as van der Waals force, but here it involves formation of bond, chemical bond. Formation of chemical bond means transfer of electrons, that is due to transfer of electrons. Second point, heat of adsorption is generally very less. Very less than that of (40 kilojoules per mole). Here in this case, heat of adsorption is more than that of more than that of 40 kilojoules per mole. Third point, it is reversible. What is reversible? It is not reversible. Reversible means whenever the solid particles is adsorbed at the surface by any physical means, we can also get it out again from that adsorbate. That is a reversible process, but it is not possible in case of chemical adsorption because it is forming the chemical reaction by the formation of bonds. In fourth cases, it is a general phenomenon which can occur any solid gas system. It is occurring any gas solid system provided the condition of temperature and pressure is suitable. It is only taking place if the gas is capable of accepting or forming a chemical bond. Next point, multi-layers may be possible. Because at the surface, after another, the layers can be accommodating or attaching the adsorbate molecules, but here only the single layer, only monolayer is possible. Only single layer. Next point, it is appreciable at low temperature and high pressure. But in this case, it can occur even if at high temperature. And decreases with the pressure, increase of pressure. With increase of pressure. Next point, it is applicable or appreciable of activation energy or appreciable activation energy is involved. Energy is involved. But it is an activated phenomena. activated process involves activation energy. Some other points also there. Next point, it is an instantaneous process. Instantaneous process, whereas it is rapid or slow. Rapid or sometimes slow. It is a function of average average surface area covering. Coverage, but here it is only obtained at fixed sites that is at active centers. Active centers. So this phenomenon, it is not specific. Whereas it is very specific in nature. So, considering the physical adsorption and the chemical adsorption, we have dealing with so many points. In that cases, the main thing is that the adsorption depends upon temperature and pressure, as because it is a exothermic process. So, decreasing temperature also increases the adsorption, and sometimes the chemical bond is formed due to chemical adsorption. So, these are the things we have discussed, but the thing of another cases, that is dependency of temperature and pressure. That is factors influencing adsorption. The first case, temperature and pressure plays important role in case of adsorption, and second, nature of adsorbate or adsorbent. And another is that So, only we will deal with temperature and pressure as the nature of adsorbent and adsorbent on which the attaching substance is taking out. That means when adsorbent is more positive, that means it attract the solid particles to attach at its surface. That is why more will be the adsorption. Similarly, if the nature of adsorbent, that means the solid particles will forming or attaching towards the adsorbent, then the adsorption is more. But the temperature and pressure plays an important role in the case of adsorption. As it is a exothermic process, the decrease in temperature and increase in pressure shows the more adsorption. That is why Friendly's adsorption isotherm shows that the adsorption is directly proportional to pressure. So, adsorption means the amount of adsorption x by m, where x is the amount of adsorbate and m is amount of adsorbent is directly proportional with pressure to the power 1 by n, or it is x by m is equal to k into p to the power 1 by n. K is the proportionality constant and n is also another constant. K is proportionality constant. And n is also constant and is a positive integer. Is positive integer. That means n value is more than that of 1. So, considering this, if you will take this log of both sides, what happens? Taking log of both sides, log x by m is equal to log k plus 1 by n log p. You see here, if you will take as the equation of a straight line, y equal to mx plus c, that means it gives the equation of straight line when we plot log p versus x by m. But if we consider the amount of adsorption with pressure or concentration, that also decreases. But here, if you will plot a graph log p log x by m, that gives a straight line like this. So, it intersects at the axis, that value is log k. From this intercept, we can calculate the value of k, that is the proportionality constant, and from the slope anywhere, the slope will give the value of 1 by n. Sometimes instead of taking the pressure, we can also take the concentration. So, we can change this form, that is log x by m equal to log k plus 1 by n log c. C is the concentration. So, sometimes we can also implement or apply the equation 4 in place of the pressure. So, this is the experimental observation, that means the plot will give the value of proportionality constant and the value of the slope, from which you can calculate the value of n. But in actual fact, this experimental observation shows that if pressure increases, there is the deviation of this curve. Deviation of curve means this straight line is not giving a proper angular straight line, but at the high pressure it gives a curve. Why? Because this absorption at high pressure, whenever it is observed at 1 by 1 layer, so this is only valid at low pressure, and at high pressure the deviation is there. So, it can be eliminated in another form, that is beyond our limit. So, what are the deviation or what are the limitations of this Freundlich adsorption isotherm? All these things we have discussed at a particular temperature, that is why it is known as isotherm. So, at a given temperature, this amount of adsorption is proportional to the pressure to the power 1 by n. Now, coming to limitation. Limitation of this Freundlich adsorption isotherm. First point, it is valid over a certain range of pressure. Over certain range of pressure. That at high pressure, the adsorption, amount of adsorption is not appreciable. Second point, the values of k and n both are varying with increasing temperature. The constant, proportionality constant k and n will vary with increase in temperature. And it is an empirical formula without its theoretical foundation. So, this is the all about the adsorption. Next subtopic, that is colloidal solution or colloids. Colloidal solution or colloids. as we have understood that when a solute is dissolved in a solvent, that completely dissolves means it gives a ideal solution. But the crystals, that means the solutes diffuse in the solvent molecules which are taken in large excess, but sometimes the particles are very slowly diffused. That means such that we have taken as gelatin, albumin and starch, they are just remaining in the solvent as a suspended particles. So, we may observe it in naked eye, or sometimes we may not observe in the naked eye. So, particle size of the pure diffused molecules is about 10 to the power minus 9 meter, that is known as nanometer. It is of a pure solvent or pure solution, ideal solution. The particle size in pure solution, that means it is diffused completely, but the size 10 to the power minus 9 to 10 to the power minus 6, that means 1 nanometer to 1000 nanometer, that is the value of colloidal particles. Colloidal particles, and more than that we will get the suspended particles. Particle size is more than 1000 nanometer. So, in that cases the particle size depends upon whether we are considering a pure solution or colloidal solution or suspended particle solution. So, in that cases colloid means that is not diffused properly in a solution and present in a suspended particle. So, that is known as colloidal state. So, what are the types of colloidal system? Types of colloidal system. One is dispersed phase, another is dispersed medium, dispersed phase and dispersed medium. That means dispersed phase is the dispersed phase is the we have dispersed phase and dispersed medium. Medium means which is taken in bulk, and dispersed phase it is the amount which is present in very less quantity. So, there is two things, dispersed phase and dispersed medium, and in that cases the dispersed phase means it is a discontinuous phase. Discontinuous phase, and it is a medium means it is a continuous phase. Suppose you will take the particles in discontinuous. When a substance is distributed within the solution, that is the distribution in the colloidal medium in the form of colloidal particles, that gives a heterogeneous phase. One is, that is, colloidal particles is in one phase, either solid or another phase, and the medium is either liquid or gaseous phase, or whatever the quantity is more than that. That means two things are available for this colloidal system. In that cases, dispersed medium and dispersed phase, depending upon these two, we can have the so many things in our day-to-day life. That is, if you consider dispersed medium, dispersed phase, and examples. First thing, if you will take dispersed medium as a gas, dispersed phase as liquid, it is cloud, mist, fog, etc. If dispersed medium is gas and phase is solid, smoke in which the carbon particles are suspended with air, smoke and dust. If dispersed medium is liquid and it is also gas, dispersed phase is gas, so it forms the foam, whipped cream. If it is also liquid and it is liquid, that means emulsion. Emulsion means paint, color, etc. Liquid and solid, starch, protein, albumin, etc. Then solid, gas, that is adsorbed gases, ice cream, cell fluid, etc. Similarly, solid and liquid, jellies, gels, cheese, butter, then solid, that is the colored glasses, and gemstones. So in that cases, what happens, the stones which are using, that is just ruby or any other things, there are some particles are present inside the solid. So these are the cases, these are examples of taking different dispersed medium and dispersed phase. Considering all the, what are the classification of colloidal system. Classification of colloidal system. Classification. In that case, we will get lyophobic and lyophilic. Lyophilic means love towards the liquid. Here lyophobic means hate towards liquid. That means love towards liquid and hate towards liquids. So in that cases, what are the things? The substances which are large enough, such as starch, protein, rubber, gelatin, and so many things, which are mixed with a suitable solvent. Suitable solvent means that is a dispersed medium, and that gives the colloidal sol or colloidal solution. In similar fashion, if we will take the lyophobic, that means it is hating the liquid, that is not forming the colloidal substances. The substances like metals and their sulfide solutions that gives, such as ferric hydroxide, gold and arsenic sulfide, which are separated, that soluble or say sparingly soluble inside the dispersed medium, and the molecules are very smaller than that of the lower colloidal limit, and the colloidal solution forms due to aggregation of that small particles. So we have the lyophilic and lyophobic substances. So considering this, if we will go, what are the difference between lyophobic and lyophilic colloids? We will have points of differences between lyophilic and lyophobic colloids. Differences. So in that cases, we will have first the preparation of lyophilic colloids. It cannot be prepared so it is easily prepared, but it is not easily prepared, or it cannot be prepared. Not easily prepared. Second, surface tension. The surface tension is the same throughout. That means as in the dispersed medium, but here in this case surface tension is lower than the dispersed medium. Viscosity. It is much higher than that of the medium. here that of the medium, it is almost equal, at that of dispersed medium. Then visibility. Visibility, the particles cannot be visible in naked eye. And also even in ultra microscope. Here it is easily detected under the microscope. Then migration under electric field. So, the particles may or may not migrate in an electric field. As the particles contain electric charges, migrate to respective electrodes. Then action of electrolyte. Action of electrolyte means adding the electrolyte substance to the colloid solutions. The electrolytes have little effect much larger quantity is necessary. For precipitation. Small quantity addition of electrolyte can show precipitation. It is reversibility. it is reversible, whereas it is irreversible. And it is not giving the hydrated molecule, whereas it is giving the hydrated molecules. So, these are today's. Next time we will study more.